Hi, Chris Kuzmal here. Today we're going to talk about truth assignments and eventually evaluation for relational logical sentences. In relational logic, every relation that there is in our vocabulary, and for every object that can go into, or any combination of objects in relations that are have an arity of more than one, we have to assign a truth value to each one of those relations. So let's consider a very simple example. Suppose our world has two objects, A and B, and we have one relation, a binary relation called likes. Well, there are four possible relationships that can exist. A likes B likes A likes A, and B likes B. Those four relationships each can be assigned a truth value, and that means that therefore there are 16. So this table shows several rows, but not quite all 16 rows. They didn't quite fit, but it shows several rows, each row corresponding to a particular truth assignment for our particular world. So the highlighted row here, this highlighted sort of in orange, shows the truth assignment where A doesn't like B likes A doesn't like A, and B doesn't like B. And now we can evaluate the logical sentence, there exists an X such that A likes X. So intuitively, we can look here, we can look for A and look for as on the first argument of likes and see if there is a one. Anytime there is, then we will get one of these to be true. And because this is a there exists, we only need one of them to be true in order for the thing to evaluate to true. But it doesn't. Neither A likes A nor A likes B. And therefore, there is no X. There does not exist an X where A likes somebody. And therefore, the logical sentence evaluates to false. We can look at a more complex logical sentence. The same truth assignment where we say that only B likes A, we could ask whether or not it's the case that for all Y, there exists an X such that Y likes X. Okay, so does somebody, okay, I mean, is it the case that everybody likes somebody? And we just saw that A doesn't like anybody. So in fact, this will also evaluate to false, but for a slightly different reason. So these two logical sentences can be evaluated in this world as I have just shown you. Now, let's remind ourselves, what is the thing that is, in other words, the set? There's a set of all the relations where they're combined with all the objects. That set is called the Herbrand base. And every relational logic has an Herbrand base, even if it isn't a Herbrand logic, which is sort of a confusing bit of nomenclature. So we call this set the Herbrand base, where you have, now we added an additional relationship, which was identifying whether a particular object is a cat. So it's a unary relation. So that's what an Herbrand base is, and we'll refer to that from time to time as we proceed. And indeed, a formal definition of an Herbrand base is the set of all ground relational sentences that can be formed from the constants, that the object constants and the relational constants in the language. So this is a more abstract example, which is identical in its combinatorics as this example, but it's a little bit more abstract, where we have object constants A and B and relation constants P and Q, where P has an arity of 1 and Q has an arity of 2. This is the Herbrand base formally shown: P of A, P of B, Q of A Q of A, B, Q of B, A, Q of B. Well, that's lovely, and I hope you enjoyed that. That is, in fact, the official definition of an Herbrand base. And we can get even more abstract and say more generally, it's a set of all sentences of the form R T1 through Tn, where R is an n-ary relation constant and T1 through Tn are object constants. And so what we would do is we'd go through each relation and each object constant for the first argument and each object constant in the second argument, and so on, in order to produce all of the elements of the Herbrand base. So when we come up with a truth assignment for relational logic, we map each ground relational sentence in the Herbrand base to a truth value. Well, the Herbrand, everything in the Herbrand base is a ground relational sentence. So every element of the Herbrand base gets a truth value, and that is a truth assignment for our relational logic. Okay,